All right, I'm guessing at the end of this meeting we'll discuss Wei Han's. Someone's echoing. No, never mind. We'll discuss Shui Han's document.
Okay.
All right, let's see. For me this week, I'm still working on. I was on a PTO last week. I'm going to be working on Classic Scrub and then Crimson Scrub for the next several weeks, I think. Yingjin, how's it going?
Yeah, I have some updates from Jianxin. He's not joined today. So the final grain cache is available for review. And Jianxin also works on the max allocation size, and there was a bug block him, and probably it is still see what is going on here with the max allocation size feature. So my work this week is mostly about reviewing the LBA tree optimization, and I will take a look at the CodeTier proposal this week, and I also plan to allocate more efforts to the multi-core messenger in probably the following weeks. That's all for me.
Okay. Let's see. Harsh?
Hey, sorry, I do not have any major updates from the testing. I do hear some echo, but I do not know. So there are not any major updates. That's because we have an issue with the recent images since the last couple of weeks. All the recent images of Crimson during the configuration of the cluster, addition of new node has not been possible.
One moment. Can you please mute?
Sorry.
Thanks. Okay, go ahead.
Yeah, so what I was saying is since last couple of weeks, all the Crimson images that I am getting from Shaman have this particular issue where when we are trying to configure the cluster and when we are adding the nodes, that is throwing an exception. I've already raised the upstream ticket for this and spoke with Nidson. He informed me that this is not an Crimson underlying issue, but rather a issue with the reef build itself. And we are not yet sure when exactly this will get fixed because I haven't found a upstream ticket for the reef.
Can you link the bug really quick?
Yeah, sure. And that is the reason why there was not much traction on the testing side. I've sent it in the chat, I believe. It is for everyone, yeah.
Oh, weird. Yeah, you'll have to talk to Nidson about it. It must be a problem with Ceph ADM.
Yeah, probably because, yeah, but that's about it.
Okay, Kevin?
Hi. So, no much update from my side. So I just want to keep the pace of the upstream development. Yeah. So.
All right. Chenmei?
Last week, I'm doing the multi-core SeaStore modification, and all the modification is done. And I do the Redos bench write reader reboot for the SeaStore alien store, and the corresponding unit test. So all works. So please review again. That's all.
Okay. Ronki?
Oh, hi. Actually, there's no much update. And the PR mentioned last week is mostly about Ceph volume and Ceph ADM. So Adam Kim is reviewing my PR. And actually, I'm still newbie in Crimson, so maybe I will spend more time in it.
Okay. Zweihan?
Okay, this week I was mainly this week I was mainly modifying the LBA pointer PR following Yinxin's suggestion. That's all. That's all. I also assisted my colleague Zhang Song to write the design documents for the non-volatile data cache. That's it.
Okay. Does anyone else have anything else to discuss before we continue on to talking about the hot data non-volatile cache document? All right, Zheyan, do you want to put a link into chat to the document?
Okay. Sorry.
No worries.
Here it is.
All right. Do you want to give us an introduction?
Okay. The purpose of this document is to describe a machinery that we propose for implementing the hot data cache function in SeaStore, in which we cache data that are frequently accessed or frequently read in the hot tier. That's the purpose. That's the purpose of this document. The design principles are as follows. First, I think to cache data in hot tiers, we need to utilize the locality of the application's access pattern on its data, and I think in Ceph object upper layer applications logical address space are partitioned into objects at the Redis level, and those objects are hashed onto a set of PGs which is scattered across the cluster. So the locality of access is across the Redis objects are somewhat lost. So in SeaStore, the locality we can see is on the logical address space of extents within the same O node. So we think that we need to construct this cache based on the logical addresses of the logical address space of within the same object. That means the cache lines can't cross the boundaries of Redis objects. So that's the main principle. And in SeaStore, we think there are two types of data. One is the metadata of SeaStore itself. It contains LBA extents, backgraph extents, and O-node extents. And the other type is data from upper layer applications, like object data and OMAP data. And we think that the access pattern of these two types of data are relatively different because the data access is issued by upper layer applications, and they should show obvious locality. Well, the metadata may not be the same. The reason is that the metadata are all B trees, and the keys of these B trees are basically either physical addresses or logical addresses that created based on the crush hash of Redis objects. So we think that although extents within the same object, within the same Redis object, will have contiguous logical addresses. But the extents from different objects will have completely different logical addresses, and they are evenly distributed across all the leaves of those LBA trees or O-node trees. So the logical address space of the upper layer applications are usually relatively large. Take RBD as an example. An RBD image can have several or tens of terabytes, and in Redis, objects are relatively small. I think that's basically 32 megabytes at the largest. So one RBD image can have hundreds of thousands of objects, Redis objects, and if only say 5% of its space is hot, then that hot space will still contain tens of thousands of objects, which means tens of thousands of LBA leaf nodes will be accessed equally frequently. So we think that this is the main difference in the access patterns of metadata and data. So based on this assumption, we think that perhaps we should cache data and evict the data. Cache data. We should load data from cold tier to hot tier and evict data from hot tier to cold tier, based on the data's heat. While we can rely on the current tiering machinery to evict metadata. And we think that the metadata doesn't have to be loaded back to the hot tier. This process can be they can come back to the hot tier on rewrite or mutation. That's the main principles of our design. I don't know if there are any questions about this.
So the observations about objects are essentially correct, although 4 megabytes, not 32 most of the time. However, it's still the case that adjacent LBAs... Oh, I'm getting a huge echo from you, Johan. It might just be that your microphone is too close to your speakers, but anyway. It's still the case that LBA keys close together in the LBA tree are more likely to be accessed, because they will belong, in general, to the same data portions of the same objects. So I actually think the LBA tree is going to have just as much locality properties as the data blocks it references most of the time. I'm not super fond of having a separate system for data blocks. I'm okay with having a separate policy, but we already have a tiering system. And I don't know if Yingzhen wants to jump in here and disagree, but I would be more inclined to find a way to phrase this in terms of the existing tiering design.
Okay.
Like the primary difference here, as far as I can tell, is that you're maintaining an online in-memory structure to control eviction. That's the only difference I see between this and the current tiering implementation.
Okay. I think we.
Right.
Okay, please go ahead.
Well, I'm asking if there's another substantive difference.
Actually, there are. Oh, okay.
Let me share my thoughts. So the current design with tiering is cold tier and hot tier is based on the generations, which the goal of generation is to minimize write, the overall write amplification during cleaning. So in order to make cleaning efficient as possible, and it is not designed for the hot tier to accelerate the frequent access or frequent read the extents, because I saw that if we extend the memory enough, the volatile memory enough, it can absorb, it can cover this case. So I think the Xuehan's proposal is to also add this responsibility to the hot tier, so we can promote the frequently accessed extents to the hot tier.
Right, but even that's just a difference of policy.
Mm-hmm. Yeah.
Right?
Yeah.
And again, an online structure to speed eviction, which I'm fine with, but I would be more inclined. I would encourage you to find a way to fit this into the existing tiering implementation, so that as much as possible it's shared. For example, it could be that you make the eviction policy pluggable, but different kinds of extents belong to different eviction policies, something like that.
Mm-hmm.
Okay.
I'm still not sure how to. Maybe a way is to make policy pluggable, so we can choose different policy, for example, to minimize write authentication or accelerate frequently accessed extents read, or maybe they can co-locate together. So yeah,
Well, I
think
mean, they seem pretty orthogonal, right? So with your existing implementation, as I understand it, extents only go from hot to cold. They never go the other direction.
yeah.
But there's no reason why that has to be true. There is no actual on-disk state for tiering, right? It's just what the LBA tree points at. Correct?
Sorry, I didn't follow your last point.
The only on-disk state like that tiering actually has is that the LBA tree can point at more than one tier. So when we relocate something from a hot tier to a cold tier, we simply update the LBA tree with its new location.
Yeah.
The opposite motion should be semantically identical. You simply
Mhm.
rewrite it to the hot tier and then update the LBA tree. So it would be adding that capability as well as the appropriate hooks in the read path to allow it to happen. And then orthogonally to that, and this could be done separately, there would be this extra in-memory structure for speeding eviction from the hot tier. But that may not even be necessary. You can pursue these two things independently. You can first add promote on read. That promotes things back into the hot tier, and then separately look into this different eviction strategy. I'm a bit skeptical of this eviction strategy because I think it's going to use quite a bit of memory, and reconstructing it on startup strikes me as mildly expensive. But I'm prepared to be convinced once you have, more numbers. But it's possible that once you've implemented the promote part, it will turn out that the eviction part doesn't matter because the existing eviction policy is fine.
I have one question. The eviction of data needs to be based on the data's heat, right? We need to we probably want to avoid evicting hot data to cold tier. So
well, a couple of ways you can do that. One of them is you can, as Yingjin said, I don't think we currently have it. Does the SeaStore read cache currently keep an arbitrary amount of data in it, or have we made that change yet? Do we actually keep in memory state in SeaStore?
Which memory state?
That is, SeaStore has an LRU that keeps a fixed minimum amount in cache, right?
Yeah, it's volatile.
Okay, cool. Yeah, of course. So that's going to absorb some of the read locality. It would be interesting to measure how much. The other piece is there are strategies other than an explicit linked list of addresses. You can use time decaying Bloom filters to do a sort of a lossy estimate of whether extent ranges have been recently read. And there are other tricks like that. You lose them on startup, of course, but that's not necessarily a big deal. Anyway, so I think what I'm pointing out is there's more than one way to do the eviction part and the heat estimation part that use more or less memory to get more or less accuracy. And I'd encourage you to think about that when you're doing the design and try to make it pluggable so that we can change it later.
Okay. I think I have to give more thoughts on that part.
But I think the promote on read part is probably just a good idea, and that's probably worth doing first.
Sorry, I didn't hear the last sentence.
The piece of this where we promote an extent on read is probably worth implementing first, independently of the eviction part. And I want to suggest one other thing that may not be totally obvious. SeaStore is not the first cache in any system it'll be running in. It's the second one. So any RBD block device that isn't sitting behind FIO will be in a virtual machine with probably Linux running. That Linux will have a page cache and its own read cache. So it's actually, you may find that in real life, it's improbable that you get successive reads on the same block, because the first read's going to load it into the virtual machine's cache.
Yes, but what the scenarios that we are considering is we put Ceph processes and application processes all within the same machine, and that will make the memory very very expensive, because a single machine can own maybe several hundreds of gigabytes of memory, but it will a lot of applications will have to share those memories. So the memories that the page cache might be using could be very limited.
It's the other way around. You'd want the VM to use as much page cache as possible. You would never prioritize SeaStore's memory in that scenario.
No, I'm not saying SeaStore's memory. I'm saying that since the memory that can be utilized by page cache or any kind of cache is very limited, we will need the hot tier to serve as a secondary level cache. Is that right?
I see what you mean, but it's still the case that the page cache will be non-zero. So the most frequently accessed objects will be the ones you least want to cache. It'll be the minimum. It'll be the middle ones.
Okay. Yeah. Okay.
None of this means that you shouldn't implement a more clever eviction policy than what already exists. I'm just suggesting that it will pay to make it pluggable.
Yeah. Yeah.
And I think it's going to be less important than the promote on read. I think that's all my thoughts. Yingjun, do you want to cut in?
Yeah, and I think I've delivered my thoughts, and I will put more in the document later.
Okay. So shall we go on?
Does anyone else have any thoughts on this proposal? All right. Sounds like we might be done for the evening. Does anyone have anything else? If not, have a great week.
Okay.
See you.
See you.
Bye.
Thank you. Bye.
Bye-bye.